Hello everybody, welcome to the third video for cumulative review number 12. We're going to start here with number 12, actually. Convenient. So if we take a look at this parabola, we, without a calculator, want to try to guess what the parabola is doing so we can move it around the graph without a table, without finding the x-intercepts or anything. And the reason we can do that is all of these are currently in vertex form, which means that we will see the vertex eventually, and that'll help for later problems on this review. First, does the graph face upwards or downwards? Well, in front of the parentheses, I don't see any negatives, which means the parabola must be facing upwards. Is the graph wide, narrow, or normal? Again, because I don't see a number in front of there, I assume it's 1. And so if this number is 1, the graph is going to be completely normal, meaning it's not changing width at all. Shifting questions. If I take a look at the number inside the parenthesis, this number is either going to be left or right because it is by the x value. Now, which one is it? Inside the parentheses is always opposite of what you think. So I'm going to write a little note here. It's always opposite of what you think. So if I see x minus 2, that really means that it's going to the right. So does this graph shift left or right? Yes, it does. It shifts to the right. If so, how many spaces? 2 units. Does the graph shift up or down? To determine this, it's the number that's either added or subtracted onto the end. And I'm trying to do it color coordinated here to help you. So because I see a plus 5, the y values do exactly what you want, what you expect. So because I see a plus 5, it means that this graph is moving up 5 units. If I looked at number 13, it asks me first, is the graph facing upwards or downwards? Because I see a negative in front of the entire parabola, I know it has to be facing downwards. Is the graph wider, narrow, or normal compared to the graph of just x squared, or y equals x squared? Well, that's when the 7 comes into play. Whenever I see something that's multiplying by 7, and it's not negative 7 because that negative has to do with it flipping downwards, but if I look only at the 7 here, I'm thinking about that the whole graph is being multiplied by 7. So your gut thinks, well, if I'm multiplying by 7, the parabola should get bigger, but again, this number is again opposite of what you'd think. So it's not going to get wider, this graph is going to get more narrow. Because I do not see any parentheses, so there's no parentheses in this problem, which means that the graph is not shifting left or right. So I'm going to put no for both blanks here. However, I do see a minus 3 at the end, so this is having to do with y values, so this is either moving up or down, and y does what you want. So in this case, the parabola is going to shift downwards 3 units. If I looked at 14, I see a few things going on here. Does the graph face upwards or downwards? Well, in front I see a 1/2, but it's positive, so my graph is still facing upwards. Is the graph wide, narrow, or normal? Well, it's definitely not normal because I have a 1/2 in front. If you're multiplying everything by a half, you think about that everything's going to get smaller, but it's the opposite of what you'd think. So this parabola is getting wider. In terms of shifting questions, I do see parentheses this time, which makes me think it's either going left or right. And this is, again, the opposite of what you'd think. So if we're going plus 4, we are really going to the left 4 units. And if I see the minus 1, the y values do what you want. And so because it's negative, we are going down 1 unit. All of this is there to help us with the next problems, to understand where the graph is moving. So for 15, parts A and B, both of my graphs are in vertex form, meaning you can see where it's shifting. So the first thing I would just want to write down for you is that if I see an x minus 1, that means we're really going to the right 1. And if I see a positive 5, that really means I'm moving up 5 units, which means my new vertex would be at 1, 5. Now, all parabolas originally start at 0, 0, so assume it starts here. So if I'm going over 1 and up 5, that's why the vertex starts here. And after this point is when you use the pattern we talked about in class. As soon as you see a parabola, think about the parent function x squared when there's nothing happening to it. If we do a quick little table and we plug in our favorite values, -2, -1, 0, 1, 2, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is back to 4. This not only is a table to help explain where the parabola comes from, but also these are movements. Meaning, this -2, 4 you could view as left 2, up 4. You could view this movement here as right 2, up 4. So from this point, we're going to follow these movements. We're going to go left 2, up 1, 2, 3, 4. Left 1, up 1. 0, 0 is where I am right here at the red vertex. Then I'm going to go over 1, up 1, and then over 2, up 1, 2, 3, 4. And if I did this correctly, my parabola should look symmetric, like this. And on your test, I do need to see these specific dots. You need to be very clear, and you could make them as big as I am right now. I am going to be looking for if you understand that these are movements. So please be careful about that on your test. And so in summary, when something's in vertex form, you can look at it and say, ooh, this is going to the right 1, up 5, so I'm going to shift the whole parabola up and just use the quick movements instead of doing this from earlier in the video. We don't have to do this stuff because this is in standard form, but these are in vertex form. Part B, this is no longer a quadratic equation. This is now an absolute value equation. But absolute value does act like a parabola. So the first thing I want to think about is what my new vertex is or what it's moving to. If I see a +3 in here, this really means I'm moving left 3 units. And if I see a -2, that means I'm moving down 2 units. So the first thing I'm going to graph is that vertex. So I'm going from 0, 0, left 3, down 2. Here's where my V shape is going to start. It's a V because of absolute value there. Now I notice that there's a negative in front, which means that this entire graph does flip, and that will come into play in just a little bit. If I make a quick little table for the parent function y equals the absolute value of x, and I plug the same values into that, think of them as movements again. If I do the absolute value of -2, that's a +2, because absolute value is a distance, and distance is always positive. Absolute value of -1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. So these are movements. So we're going, left 2, up 2, left 1, up 1. But what I want you to see again is that because I have a negative in front, this V is going to be upside down. So it's going to be the same pattern the other way. If I look at these two patterns first, I'm going to go over 1, down 1, over 1, down 1. And if I look at these two patterns second, I'm going to go over 2, down 2, over 2, down 2. If you take a look again at a V, it makes sense that the slopes on both of these are going to be straight lines. So it's going to be up 1, over 1, up 1, over 1, up 1, down 1, up 1, down 1, like that, because it's a V instead of a U. So what you need to think about is when you're studying for your test, please remember this pattern for a parabola and this pattern for a V, for an absolute value graph. And again, I will be looking for these specific points, so please be careful. Last but not least, number 16. 16 gives you the graph, and we're trying to go backwards to find something like A or part B in that format. So we already gave y equals, so let's first figure out where the vertex is, because that helps determine where or how I could write my equation. Looks like my vertex here is at -5, -4, so I'm going to write that here. And this is a U shape, which means I have a parabola. So it's going to be in the form x minus h squared plus k, h and k being your vertex. Notice that the parabola is upside down, which means in front of my equation I need a negative. So I have y equals negative. The x value of my vertex is -5. So it would be x minus -5 squared plus -4. And then if I simplified this a little bit farther, I'd have y equals negative x plus 5. So I'd have x plus 5 squared minus 4, because you don't need plus a negative necessarily. So this would be the equation in the end. And so you could have put that in the blank up here. But just be aware, as soon as you see a parabola, you're going to have to have something squared, because that's the only way that you can make a parabola on your graph. And also, based on the previous examples, I wanted to remind you that if your graph does go left 5, it does make sense that your original equation had a +5 here, because when you looked at this direction, it was always opposite of what you thought here and here. So it would make sense that if we went left 5, that it would really be a +5 in here. This next example looks like a V, so this is absolute value. So my equations, the general equation is going to be something like the absolute value of x minus h plus k. This time, the absolute value is facing upward, so I do not have a negative in front. The vertex looks like it is at 3, 5. So if I thought about plugging this into my equation here, I would have y equals the absolute value of x minus 3, because the h value is the x value of your vertex, and then plus k would be plus 5. And again, if you think about it, this has to be my answer, because I do not have a negative in front, which means the absolute value is facing upwards. If I had this equation originally, if I looked at x minus 3, I would think to the right 3, which is what the parabola did. And if I saw plus 5, it would go up, which is what this absolute value graph did. Not parabola, absolute value. In this one, just to go back to, if I looked at this, I'd say this is going left 5, down 4. It went left 5, down 4, negative in front because it's flipped upside down. All right, guys, feel free to rewatch any part of this video. Best of luck on your test. Feel free to ask questions in class.